Good morning. How are you doing? Can you hear me okay? Yes? Okay. My name is Amie. I do iOS at Airbnb. And in this presentation, I'm going to share with you how we implemented routing at Airbnb. This is today's agenda. First, we're going to get a little more context on the Airbnb app and discuss what routing is. Last year, we introduced routing for the first time, and I'm going to show you what kind of problems that we ran into and how we addressed them. And this year, we did another deep dive into routing and came up with an implementation based on intent handlers. And finally, we are going to look at other alternatives and discuss their trade-offs. And I'll close it by sharing some of the lessons that we learned during this process. The Airbnb app is designed for hosts and guests around the world. We want our guests to feel like they can belong anywhere while they are traveling, and we help hosts to run their business by renting out their houses and hosting an experience. Who here has used Airbnb app? Okay, great, thank you. So Airbnb app was published in 2010 for the first time. So far, it has been contributed by over 400 engineers. It has over 1 million lines of code with 10,000 source files and over 300 modules. It provides various features like product discovery, booking, reservation management, verification, host management tools, to name a few. So the complexity of the product and use cases constantly forces us to reevaluate how we can build features and how we can work together. So switching gears to routing. Routing in the web context refers to a mechanism of converting a URL into a software component that can handle that specific path and query parameters. So if you're familiar with Rails, the router matches the incoming request with a resource and controller actions. And developers can redirect to another URL quite easily with its routing API. Node.js app also has a similar concept of routing. So what is routing in native platform? Let's look at how we navigate from one feature to another feature in the Airbnb app. This is an example of navigation from product to host profile, and then again to product screen. First, we go to product, which has information on its host. So when you tap on the host row, we navigate to user profile screen. And if the host has other listings, you can tap one of the listings and navigate to a product screen. And how does this look in the code? If you have a single module set up, you construct a view controller, in this case, a user view controller, and then you push it onto the navigation stack. Pretty simple. However, what if product and user profile screens are defined in different modules? At Airbnb, each feature module contains an isolated feature maintained by a single team. So this modular setup allows us to reuse and share features, test them in isolation, and improve the build time. So later today, at the last presentation of the day, my colleague Francisco is going to discuss how we manage this multiple module app effectively. So that in the diagram, blue ones are feature modules. They are user-facing features such as product, user profile, and registration screens. Red ones are service modules that can manage shared state and resources, such as network service, account service, and logging service. And through the app target, a feature module gets its dependencies injected. When we navigate from product to user profile, we need to import the destination module, user profile feature in this case, that contains the definition of user view controller. For the reverse navigation, user profile feature also needs to import product feature module to instantiate the product view controller. This direct instantiation approach results in a circular dependency as both modules depend on each other. And if the feature has many entry points, it can complicate the dependency graph quite a bit. In the Airbnb app, in addition to product screen, there are many other entry points that can trigger the user profile screen, like booking, identity, reservation, itinerary, and reviews. And all these feature modules need to wait for user profile to finish building before they can start building. So this strong dependency introduced for navigation purpose can slow down the overall build time, and we want to parallelize building as much as possible. So going back to this example of navigation from product to user profile screen, how can we remove that dependency to user profile and still navigate to it? A quick workaround is to pass in a builder block into product view controller and execute the block to get an instance of UI view controller. If the screen has many outgoing routes, all of their builder blocks would need to be passed into the constructor, and the setup can get quite complicated. Another workaround is to define some kind of abstraction around navigation, such as using command pattern. However, because the command class needs to be able to construct all the destination screens of user profile screen, it needs to live in the main target, and any code that lives in the main target are not reusable. So based on this discussion, routing in the native context is a feature navigation API in a multiple module environment. It provides a decoupled navigation mechanism with a clear set of API. So with this definition in mind, how do we tackle routing in our app? The goals for the first version included being able to navigate to another feature without importing its module, establishing a pattern for route definition and integration, and reducing code complexity with navigation logic. The way that we did this was through Swift protocol composition. So in product module, we declare an outbound routable protocol with a route method to user profile. And in user profile module, we declare an inbound routable protocol and repeat exactly the same route method. Each feature has a module router class that contains implementation for navigation and presentation. This way, product owners have full control over how a view is constructed and displayed. And with this setup, note that these view controllers can stay internal in their module. In the main target, we have a router class called app router that conforms to all of these routable protocols. And it calls the corresponding module router to perform navigation. We inject this app router instance into features, and within this module, the app router is known as outbound routable and is only aware of the routes that it navigates to. We can call route to user method as it's defined as one of the outbound routes, and this allows us to navigate to user profile without importing its module. So how do we do in terms of adoption? Within our app, we have a number of different architecture patterns, such as coordinator, worker, and MVVM. And this approach is agnostic of feature architecture and still allows us to have a unified navigation API. And product owners can implement routing in small pieces, and over 60 features adopted this pattern after 1 year. However, after using this approach for a few months with different use cases, we identified the following problems. Because it relies on convention, it resulted in inconsistent implementations, especially with route methods and module routers. Because route definitions were duplicated through protocols, if there's any change in a single route, all the outbound protocols needed to be updated and reviewed by all the product team members. All route methods are required, so in a brand new app, its app router could not pick and choose the routes that it's going to consume. And it requires too much code in the main target, and any code that lives in the main target is not reusable. So we went back to the drawing board and discussed product and engineering requirements within the Airbnb app. After a few months of discussion, we landed on a new proposal based on intents and intent handlers. Intents are used in popular platforms and frameworks such as Android, SiriKit, and Alexa. On Android, intent is a primary messaging mechanism to start an activity and display a new screen defined in another component. It fits as a routing mechanism as it decouples implementation details from its consumers. Consumers can pick and choose intents, and there is a concept of interceptors that can serve as additional hooks. And before I get into the proposal, there's another important concept we introduced called interface module. Interface modules are lightweight modules that contain shared model and behavior definitions, such as classes, structs, and protocols. Each interface module is associated with other feature module or a service module, and they do not contain any business logic. Rather than importing heavyweight modules that contain concrete implementation, we import its abstractions and shared models to simplify the dependency graph and reduce the build time. So in the same example that we used, we have product and user profile feature modules and their interface modules. User profile routes are defined in its interface module, and the consumer of the route, product module in this case, imports user profile interface module instead. So here are the key ideas behind the new routing system, and I'm going to go through each item and show you code examples to elaborate. Number one, a route is represented as a model. So in the new system, we have route protocol defined in the router service interface module, serving as a unified type. A route model contains a set of required and optional parameters. In this example, the minimum requirement to navigate to user profile screen is user ID. If the consumer happens to have a user model, they can construct a route model using the user model so that we can populate the user name and user picture without having to make that additional API request. The consumer constructs a route model before performing navigation. This example is showing product view controller constructing a user profile route before navigating. Number two, router service resolves a route and then performs navigation. The consumer would have an instance of a router service injected into its feature, and we call navigate on the router service. It finds the corresponding route handler associated with user profile route and performs navigation. Number three, a route is registered with a route handler. Route handler protocol defines two methods, destination and navigate. Destination returns a UI view controller, so the consumer can present it in any way. Navigate performs navigation with a default presentation style the product owner indicated in their route handler. So this provides flexibility for the consumer so that they can customize presentation style if they need to, but still gives the product owner an option to specify a default style. Number 4, a scope or feature can register route handlers. A scope is a set of dependencies and values backing a feature. App scope contains all dependencies within the app, and each top-level scope, visitor, guest, and host scope, contains a subset of app scope. The top-level scopes register its route handlers when the view displays, and then they get deregistered automatically when it's removed from the view hierarchy. By supporting dynamic registry of route handlers, the routing system adapts to the current user context and prevents any unpredictable routing behaviors. For example, if you're already logged into the app, the routing system should not navigate you to registration screens. If we hadn't supported dynamic registry, the opposite would be static registry, where all the routes and route handlers are registered once and don't change during the app's life cycle. And technically, this could allow you to navigate to areas that you normally don't have access to. And this is showing how we register route handlers for guest scope when its view controller is presented, when it's constructed. And lastly, interceptors define a precondition. Interceptors allow product engineers to add more customization. An example here is authentication required interceptor. It's designed to protect some of the routes from unauthenticated users. If a route should be auth protected, you conform your route to auth required route protocol provided by registration interface module. And the router service ensures that if the user is not logged in and your auth required route was just executed, it triggers registration route instead. And only if the result from the registration route was successful, meaning that you were able to log in successfully, it redirects to your original route. So that covers key ideas behind the new routing system. And as you can see, it's much more complicated than the previous version. But we felt that our app's use cases required more advanced routing features. Here are some of the alternatives that came up during our discussion. URL-based routing uses web URLs as feature navigation API. This approach translates well from web product, and it's very easy to, or straightforward to implement. However, it's difficult to represent complex routing parameters, and parsing strings to models can be error-prone. This is another approach using a central router that delegates to a feature router. Some of the pros were that it's easy to discover routes because routes are namespaced by modules, and the route precondition is abstracted as a plugin, and we did use this idea in the final proposal. However, initiating a route requires two pieces of information: route identifier and route parameters. And this uses static route registry, which we wanted to avoid using. So at the end of the day, we went with intents and intent handlers. Route models are very extensible. We can define additional protocols to add more characteristics to a route. If we conform a route to equatable, we can prevent the same route from being executed again. If we conform it to quotable, we can represent routing action in the API response. There is a single source of truth, which is the route handler registry in the router service. At any given time, you can inspect the mapping table in the router service and see which routes are available. API is simple and consistent across features. Interceptors provide advanced customization. And lastly, dynamic registry adapts to where the user is in the app. So lessons learned during this multi-phase development process. This is stating the obvious, but when you settle on a solution, there's always room for improvements. So be open-minded and look for opportunities to improve. You can't make everyone happy. What really helped us in the process was to list all the product requirements and engineering requirements. We rank them, and we try to satisfy the top ones really well. And we had good reasons if we ended up not supporting them. Don't forget developer productivity. Routing is an infrastructural feature, and it was important to be mindful of developer productivity to help with adoption. And there's no single right solution. All of the approaches that I mentioned here are valid, and it really depends on factors like the size, use cases, and the existing setup of your app. So make sure that you understand the trade-offs and be intentional when you make a decision. Thank you.